Hello, my name is Melanie Martinez. We'll be talking about Newton's first law. Newton's first law is one of the foundational principles of classical physics. It describes how objects behave when no net force is acting on them. This law is often called the law of inertia. Inertia is the tendency of an object that is to resist changes in its state of motion. More mass means more inertia. A force is a push or pull that can change an object's motion. Isaac Newton introduced this law in 1687 in his book he created, the Philosophiae Naturalis Principia Mathematica. Before Newton, many believed that a force was needed to keep something moving. He showed that motion continued naturally unless something else interfered. For my related field, I use nuclear physics. Nuclear physics studies the behaviors and interactions of atomic nuclei and subatomic particles. This focuses on forces like the nuclear force, radioactive decay, and energy transformation. Newton's first law connection is that during nuclear reactions, particles like neutrons or alpha particles travel in a straight line unless acted upon external forces. Inertial motion is key in particle accelerators where particles are kept in motion until deflected or collided. An example is a neuron emitted during fission, which continues in motion unless it hits another nucleus or is absorbed. My relevant scientist is Galileo Galilei. Galileo was born on February 15th in 1564 in Pisa, Italy. He died on January 8th in 1642 in Arcetri, near Florence. He was known for being extremely independent and unafraid to challenge authority. He came from a musical family. His father was a lutenist and a musical theorist. Galileo studied medicine at the University of Pisa, but switched to mathematics and natural philosophy after discovering his true passion. Then later on he taught mathematics at University of Padua, where he also did many experiments. He also developed the concept of inertia through inclined plane experiments. This directly influenced Newton's first law. He created a thermoscope, which is an early thermometer, hydrodastic balance, and a military compass. Newton, Einstein, and countless others also built on his work. He was often called the father of modern science. Thank you.
Hi, this is Trevor Rosetta. I'm here to present my portion of our group project on the law of inertia. So let's jump right into it. So Newton's first law of motion, it seeks to describe the relationship between objects and the forces that act upon them. The law essentially states that an object, whether it's moving or at rest, will remain in its present state until or unless something else acts upon it to change that. A body in rest will remain at rest, a body in motion will remain in motion. And you can see I included the clip art piece here of the soccer ball just to kind of help illustrate that. So we can see in the top panel the soccer ball at rest. It's going to remain that way until or unless something causes it to be in motion. And once it's in motion, like we see in the bottom panel, it's going to continue that way until something puts it back at its original place of rest. So moving on to related fields, I did some digging and chose kinesiology, which I think is very interesting. So this is the study of human movement. It's very, very relevant in the fitness world. And Newton's first law of motion, has a lot to do with this field, as the body's movement depends on certain variables like force and inertia, friction. The example that I gave here was that of a runner. So a runner, regardless of what shape they're in, must be able to apply a certain amount of force to put their body in motion, right? Now, once they're in motion, the body's going to continue in motion until certain forces act upon it. Things like friction, gravity, muscle resistance that will slow the person down and eventually put them back at a stop. Getting into scientists, I chose to cover Rene Descartes. So Descartes was born in 1596, died in 1650. Uh, he was a French philosopher, scientist, mathematician. He was most remembered for his contributions in philosophy. A lot of us have heard of the phrase "I think, therefore I am," cogito ergo sum. This marked a very real turning point in terms of Western thought, kind of shifting away from the late medieval scholasticism into more rational based philosophy. Now, aside from this, Descartes developed an early version of the law of inertia. He was not the first to do it, but he was one of many in his time. And these, of course, his work as well as many others, were important precursors to Isaac Newton's own laws of motion, which are kind of accepted as fundamental principles in physics now. The only thing with Descartes' version of this law is that he didn't account for certain variables, like, for example, mass, acceleration, force. He recognized that an object is going to remain in its state until something acts upon it, but he didn't go as far as to define what those things were that would act upon an object in order to change it. Um, Regardless, it was very, very important. I think this was a very important development, and it's definitely shaped our understanding of physics today in a very fundamental way. So that's going to conclude my portion of the project. I appreciate you listening, and that's it.
Hi, my name is Stephanie Sanchez. We'll be talking on Newton's first law in this presentation. It is a basic principle in modern history. Newton's first law of motion is also known as the law of inertia. It states that a body that is at rest or is moving at a constant speed will remain so until a force acts upon it. The related field that I picked is engineering. Engineering is fundamental in Newton's first law because it helps engineers predict how an object will behave. The connection is it is fundamental to a mechanical engineering as it describes how objects respond to forces, influencing the design and analysis of mechanical systems. An example is mechanical engineering, designing brakes in a car to overcome motion with friction. Sir Isaac Newton. Sir Isaac Newton was born December 25th, 1642, died March 20th, 1727. He is famous for the three laws of motion, discovery of decomposition of white light, integrated the phenomena of colors into the science of light. He also explored physics and mathematics.